The next topic is optimal tree problem, Huffman trees and codes. This topic is about what is called as coding and decoding. Okay, so especially this coding and decoding, these are the buzzwords that are used, especially in the compression. So what do you mean by compression? So compression, so reducing the size of the data for the purpose of either storing or transmission of the information. Okay, so in compression, what we do is given a message, we encode it by assigning different code words to different characters, and we either transmit or store it. Okay, so if at all we are transmitting, we will be efficiently using the available bandwidth. If we are storing, then we will be efficiently using the available storage. Okay, now at the receiver side, I mean, whenever we want to retrieve the data or receive and read the data, then we will have to decode it. Okay, therefore, for the purpose of encoding, we use the code words. We use code words for different characters. Okay. So when I say the code words for different characters, so we have the characters A, B, C, like this, isn't it? Then all the numbers, all these, the standard 128 sequence of characters. Okay. And the standard coding is, so standard coding, which is a standard coding? Yes, that is ASCII. Yes. So this standard ASCII coding makes use of 8-bit code words for each of the characters in the 128 character set. Okay. So this ASCII defines the standard 8-bit codes. Standard 8-bit code word for each of the character. Okay, so for character capital A, the decimal value is 65, and if we convert it into binary 8-bit value, so that is the code word for character A. Okay, so here you can observe whether it is a character A, whether it is character Z, whether it is a character dot, whether it is a character underscore. What is the number of bits? It is 8. Yes, the number of bits in the code word is 8, which is fixed for each of the character, and such kind of coding is called as fixed length. Okay, fixed length encoding. Okay, so where, as the name indicates, we use code words to encode the data, where the number of bits in each code word is fixed. In this example, ASCII example, it is 8. Okay, right. Now this one I will give one example where you can construct code words of yourself, of having less number of bits also. Say for example, you are transmitting some information A, B, C, D, B, underscore A, C, something like that. I mean, you want to transmit this information from one end to another end. Now, how many distinct characters you are using? It is A, B, C, then D and underscore. These are the distinct characters that you are using. Okay. So can you use the same 8-bit ASCII code? Yes, of course you can use, but you also have the provision of one more custom coding. Say for example, how many characters you are using in your information? Only 5, right? Therefore, in order to have the 5 different combinations, how many bits are required? Yeah, 1 bit is required to represent 2 combinations. 2 bits are required in order to represent 4 combinations. Similarly, in order to represent 5 combinations, you need 3 bits, right? So some example coding I will show like this, isn't it? Done. So this is also fixed length encoding. Fixed length encoding, where you are using how many bits per character? It is 3 bits, isn't it? You are using the 3 bits, 3 bit characters per character. Okay, so when you have fixed length encoding, okay, fixed length encoding, so another variant of encoding is called as the variable length encoding. Variable length encoding. Okay, in fixed length encoding we have the code words of the same number of bits. In variable length encoding, yes, we have the code words of different lengths for different characters. As the name indicates, we have the code words with different lengths for each of the character. Done? Okay. So therefore, which is the best way to construct the variable length encoding is Huffman coding. Huffman coding and constructing the Huffman tree. Okay, so this variable length encoding was first derived by David Huffman. David Huffman, and hence this type of encoding is named after the name of the scientist, and hence it is called as the Huffman coding. Okay, right. So in the Huffman coding, the Huffman makes use of this advantage in the message. What is that? He uses one advantage or one trick. So what is that? So a character if a character is repeating more frequently, if a character is repeating more frequently, then make use of less number of characters, make use of less number of bits to encode it or represent it. And if a character is appearing less frequently, then you can use more number of bits. Okay, so if a character is appearing more frequently, use the shorter code words. If a character is appearing less frequently, use the larger code words, larger length codes. Okay, right. Therefore, how he exactly achieves this, we shall see with an example.